Okay, video 5 on work energy power. Question says, what size electric motor will be needed to raise 60 kilos of concrete 72 meters in 2 minutes? Okay, so first thing we want to do is want to sort of mine it for information. So what's the question? The question is, what size motor? And how do we calculate motor size? We calculate motor in horsepower. And we know horsepower is equal to power in watts divided by 746. What else do we know? We know we've got, it's got to be done in 2 minutes. It's got to go up 72 meters. The mass is going to be 60 kilos. So we've got a lot of information here. So go, okay, well, my horsepower is equal to power in watts. Do we know our watts? No, we don't know our power in watts. So my power in watts is going to be equal to work in joules over time in seconds. And do we know our time in seconds? Yes, we do. We know that. Okay, but we don't know our work. So we go, okay, well, let's take a look. What is our work? Our work is going to be equal to our force times our distance in meters. Do we know the distance in meters? Yes, 72 meters, so we know that. So we can move on and say, okay, well, force, what kind of force is this here? Or force, it's being raised, so our force is going to be equal to mass times gravitational constant. And that gravitational constant we know is 9.807 meters per second squared. And we know our mass, which is 60 kilos. So we'll write that down, 60 kilos times our gravitational constant, 9.807, equals, gives us 588.42 newtons. And then we can just plug that into that one there. And we say, okay, well, my force is 588.42. newtons times my distance in meters, which is 72 meters, is going to be 588.42 times 72 is 42,366. 42,366.24. And that's in joules, because it's a work. And then we can just pop that into the next formula, and we say, okay, well, 42,366.24 divided by my time in seconds. And it's got to be done in 2 minutes. So we got 2 minutes times 60 seconds per minute, because we need to get that time. Remember, that time is in seconds. So we've got 42,366.24 divided by 2 times 60 tells me I have 353 watts. 353.05 watts. And then if I take that and I pop it into that formula, my wattage, divided by 746 watts per horsepower, tells me I need a 0.473 horsepower motor. So I would say half horsepower motor required to raise 60 kilos of concrete, 72 meters in 2 minutes. Okay, next one. How much work is being done when a 100 kilo load is being pushed 500 meters at a rate of 10 meters per second? Okay, so what do we want to know? We want to know work. How much work? So let's take a look at the work formula. Work being equal to force times distance. Force in newtons times distance in meters. Do we know force? No. Do we know distance? Yes. Okay, so let's take a look at force. The force in this is going to be equal to the mass, which we know, times the rate of acceleration. We're not lifting it, so we don't have to worry about that gravitational constant. We're just pushing it. So we say, okay, well, force is equal to mass times acceleration, and if mass is 100 kilograms, and my rate of acceleration is 10 meters per second, so times 10 meters per second, then my force must be equal to 1,000 newtons. Okay, so now I've got my force being equal to 1,000 newtons, and I know that my work is a function of my force times my distance, so I can say, well, I got 1,000 newtons times my 500 meters. So how much work is being done? Just very simply, how much work is being done? Well, how much work is being done is I got 500 kilojoules. 500,000 joules or 500 kilojoules.